Right now, somewhere above your neighborhood, a kill is taking place. A hawk is dropping from the sky. A falcon is locking on to its target. An owl is gliding silently through the darkness. And in the next few seconds, another small animal will die. The disturbing part isn't that these hunts happen, it's that you almost never see them. Millions of predatory bird strikes occur every single day in our cities, suburbs, and backyards. We find the scattered feathers. We hear the sudden explosion of panicked birds. We notice the silence that follows. But the actual moment of impact? It's almost invisible. This isn't bad luck. It's not because you're looking away at the wrong moment. It's because nature has engineered these predators to operate in the tiny gaps of human perception. And by the end of this video, you'll discover the shocking reason your own brain is helping hide one of the most violent spectacles happening all around you. Think about it. Birds of prey live among us. Hawks sit on telephone poles. Falcons nest on skyscrapers. Owls hunt in the parks and fields near our homes. They all need to eat every single day. That means countless hunts are happening constantly. Yet most people go their entire lives without ever witnessing the exact instant a hawk catches a sparrow or a falcon strikes a pigeon. How is that possible? How can a predator with a wingspan wider than your arms attack in broad daylight and still remain almost invisible? The answer begins with speed. But speed alone doesn't explain the whole story, because the real explanation is far more unsettling. The limitation isn't theirs, it's ours. When people think of fast predators, they imagine a cheetah sprinting across the African savanna. But compared to a peregrine falcon, a cheetah is slow. During its hunting dive, known as a stoop, the peregrine falcon can exceed 240 miles per hour. That's faster than many race cars, faster than highway traffic, faster than most people can even comprehend. At that speed, the falcon covers roughly 350 feet in a single second. Blink once. That's all it takes. By the time your eyelids reopen, the falcon has already crossed the length of a football field. The strike has happened, the prey is dead, and the predator is already climbing back into the sky. To us, it looks like nothing happened at all. Just a blur, a sudden burst of feathers, then silence. But surviving those speeds requires extraordinary adaptations. The rushing air could damage the falcon's lungs, so peregrine falcons possess small structures inside their nostrils called baffles, which slow incoming airflow and allow them to breathe safely during these breathtaking dives. They aren't just birds, they're biological missiles. At first glance, the mystery seems solved. Fast predator, slow humans. Case closed. Except it isn't, because Cooper's hawks also perform nearly invisible attacks while moving much slower. These birds weave through suburban backyards and dense forests with astonishing precision. They dart between branches, twist through narrow openings, change direction instantly. Watching them is like watching fighter pilots navigate obstacle courses. Yet people still rarely witness the exact moment of impact. Why? Because the problem isn't only how fast birds move, it's how slowly humans see. Everything you experience is processed by your brain. Your eyes aren't cameras recording perfect reality. They collect information. Your brain decides what matters. Scientists use a concept called critical flicker fusion frequency to measure how quickly visual systems process changing images. Think of it as the frame rate of reality. Humans process visual information at roughly 60 frames per second. For everyday life, that's enough. We can drive cars, catch balls, cross busy streets. But birds of prey operate on an entirely different level. Research has shown that falcons can process visual information at around 129 Hz. In simple terms, they experience far more visual detail in the same amount of time. To a hawk chasing prey, the world slows down. Tiny movements become easier to track. Escape attempts become more predictable. Every wingbat matters. Meanwhile, humans are trying to understand the same event with biological hardware running at half the speed. To the predator, the hunt is precise. To us, It's a blur. Your brain is lying to you. Here's where things become truly disturbing. Most people assume they see reality exactly as it is, but neuroscience suggests otherwise. Your brain constantly filters enormous amounts of information. If it processed every sound, movement, and detail around you equally, you'd become overwhelmed. So it cheats, it deletes, it prioritizes. Psychologists call one of these limitations inattentional blindness. If your attention is focused on one task, you can completely miss obvious events happening nearby, and birds of prey take advantage of this weakness every day. Humans evolved as ground-dwelling primates. Our ancestors scanned the landscape ahead of them. They watched the ground for danger. They weren't designed to constantly monitor the sky above. Even today, most of us spend our lives looking straight ahead, at our phones, at computer screens, at roads, at other people. Rarely upward, exactly where the hunters are. Birds of prey don't simply rely on speed, they rely on strategy. A hawk often attacks from angles its prey isn't expecting. Tree cover breaks up its outline. Sun glare secludes its approach. Height provides surprise. Everything about the attack minimizes detection until the final second. Then there's the owl. If falcons are missiles, owls are stealth aircraft. Most birds create noise as air rushes over their wings. The leading edges of their feathers contain tiny comb-like serrations that break up turbulence and dramatically reduce sound. The result is astonishing. An owl can glide directly overhead in near silence. Its prey hears nothing. You hear nothing. Then suddenly, impact. The hunter disappears back into darkness before anyone understands what happened. It's one of nature's most effective assassination techniques, and we've evolved almost perfectly to miss it. But even speed, stealth, and surprise don't explain everything. There's one final piece of the puzzle, a hidden process taking place inside your own head. It's called saccadic masking. Every time your eyes shift from one point to another, they move incredibly quickly. If your brain processed all the visual chaos created during those movements, the world would appear blurry and disorienting. So your brain does something remarkable. It briefly suppresses visual information during rapid eye movements. It edits reality. You can test this yourself. Look into a mirror. Stare at your left eye. Now quickly switch your focus to your right eye. You'll never actually see your eyes move because your brain erased the transition. Now imagine a hawk diving toward a sparrow. You notice sudden motion in your peripheral vision. Instinctively, you snap your eyes toward it. At that exact moment, your brain suppresses part of the visual input to stabilize your perception. Meanwhile, the hawk completes its strike. By the time your awareness catches up, all that's left are drifting feathers and an empty patch of grass. You didn't miss the hunt because you weren't paying attention. You missed it because human perception was never built to witness events unfolding at that speed. Nature exploited the gaps in your biology, and the predator slipped right through them. The next time a flock of pigeons suddenly explodes into the sky, the next time you hear frantic chirping from a nearby tree, the next time you notice a few feathers floating on the wind, remember this. Somewhere in that brief moment of confusion, an apex predator executed a hunt with astonishing precision. You didn't see it, not because it was hidden, not because it was far away, but because evolution designed these hunters to live and kill in the fractions